Good afternoon, class. We are looking at chapter 6, periodic and trigonometric functions. And here's 6.1 and 6.2 with more graphs of trig functions, phase shift, sinusoidal curve fitting. So we covered graphs of sine and cosine, others, tangent, cotangent, cosecant, and secant, and now more graphs, phase shift, sinusoidal curve fitting. So the objective would be to graph sinusoidal functions of the form y equals a sine omega x minus phi. This is omega, everybody, not w, plus b. You take this out, you factor the omega out, becomes a sine omega of x minus phi over b, and this becomes your phase shift plus b. The same thing with the cosine, and we want to build sinusoidal models from data. Reminding you, when we want to graph sine and cosine function, one methodology is to cut the period. Remember, for sine and cosine, the period is 2 pi for a basic function. So a complete cycle goes from 0 to 2 pi. You cut it in 4 equal subintervals. When you divide 2 pi by 4, you get pi over 2. So from 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, pi over 2 to 3, 2 pi gives you 5 points known as the key points. So you plot those. For sine, we have 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0. For cosine, we have 0, 1, pi over 2, 0, pi minus 1, 3 pi over 2, and 2 pi 1. And this is one arc. This is another one. This is the third arc. This is the last one. So you cut them into 4 subintervals, giving you 4 arcs, and the end points for each arc, we evaluate them, and that's the graph. So also, sine and cosine ultimately have the same graph as long as you shift them. Cosine of x minus pi over 2, which means regular cosine shifted to the right by pi over 2, gives you the same graph as sine of x. What if we have a general case? A sine omega x, a is positive, omega is positive, the period is 2 pi over omega, and so here's the case. When y is sine x or cosine x, the period t equals 2 pi, t represents the period. Amplitude a equals 1. If it's in the form of a sine omega x or a cosine omega x, where omega is positive, the period is 2 pi divided by the coefficient of x omega. Amplitude is the absolute value of a. In this case, the reason we don't write absolute value of 1, because the coefficient of sine is positive 1. So it's just a 1. In the case of others, tangent, cotangent, secant, and cosecant, the tangent looks like if you want to stick with one complete cycle and then expand it. If you look at a complete cycle right here, we choose to go from minus pi over 2 to pi over 2. It's important to understand the period is pi. And sine over cosine tells you you're dealing with a fractional expression, denominator can't be 0, and that gives you the domain, 2n plus 1 times pi over 2. That means odd multiples of pi over 2. On the other hand, what makes the denominator 0 would be known as VA, vertical asymptotes when cosine x equal to 0. The x-intercept happen when the numerator sine x is 0, so n pi 0. If instead of tan x you have tan omega x, then the period changes and all of these pi's, this one, and this one, you change it to that period. The same thing happens for cotangent, and the period is pi. For tangent, we go from negative power to 2 power to just as we did with its inverse, and then we expand it. For cotangent, we go from 0 to pi because we want a one smooth continuous curve, and then we continue indefinitely on both sides. This time cotangent is cosine over sine. Domain would be that the denominator can't be 0, so x can't be n pi, and therefore x equals n pi would be VA, vertical asymptotes. X-intercepts, when a fraction is 0, the numerator is 0. Cosine x is 0, odd multiples of power 2. Then it comes to cosecant and secant. Do you want to graph cosecant? Ignore it, just graph sine. Here's your sine function. Flip it over. And what happens is that the range for sine is from -1 to 1. That will be excluded for the range here. And wherever sine is 0, this is cosecant, becomes the vertical asymptote. In the case of a secant, 1 over cosine. So sine, and now we graph cosine, we flip it over. And to know what's the domain, what's the vertical asymptote, just tangent, make it sine over cosine, cotangent cosine over sine, cosecant 1 over sine, secant 1 over cosine, and you can figure them out. Now, in this section, we're going to look at phase shift, PS for short. Sinusoidal curves, that means either y equals sine or cosine or some variation of that. That's called sinusoidal functions. So graph sinusoidal functions, one cycle. First go with a complete cycle, and then if need be, you go indefinitely on both sides, okay? So y equals a sine omega x minus phi, and we are assuming a, omega, and phi, they are all positive, okay? Now the period is 2 pi over omega, that's what we have. And if it's been shifted by phi over omega, then that would be the beginning, because there's a phase shift, and the end, which is 2 pi over omega, we add this much to it. So take a look at what happens here. This is the format y equals a sine omega x minus phi plus b. You have to factor out the omega. So you get a sine omega x minus phi over omega plus b. You do the same thing with the cosine, in which case this is your PS, phase shift, assuming everything is positive to the right. So phi is less than 0, phase shift is to the left, and phi is larger than 0, phase shift, PS short for phase shift to the right. In some text class, instead of writing that, they write a sine of a bx minus c plus d. So they use a, b, c, d. Fine. We need to understand the concept. So in this case, t is 2 pi over omega. In this case, t equals 2 pi over b. The phase shift would be c over b. because this is b times x minus c over b. All right, here's the summary. Steps for graphing a sinusoidal function of the form y equals a sine omega x minus phi plus b, or y equals a cosine of omega x minus phi plus b using the key points. Number one, determine the amplitude, the absolute value of a. Determine the period, t is 2 pi over omega. Phase shift, phi over omega. In other words, factor the omega out, okay? So normally we start from 0, but when there is a phase shift, we start from that phase shift. And then we add a period to it, 2 pi over omega. Therefore, divide the interval with the starting and the ending points of one cycle of the graph, a complete cycle. Starting instead of 0 from the phase shift. And then instead of ending with 2 pi omega, it ends with phi over omega plus that, because we move it by the period. We cut it into 4 sub-intervals of the same length. And that means the period must be divided by 4. Use the endpoints of these subintervals to obtain the 5 key points on the graph, the same as basic sine. Plot the 5 key points and connect them to obtain the graph of one cycle. Extend on each side to make it complete. If b is not equal to 0, apply a vertical shift. In other words, you can ignore the b and do your work, and then apply the b, whatever you do, up and down, depending on the value of the b being positive or negative. Find amplitude, period, phase shift, and graph. And this is the synopsis of what we've discussed. Y equals minus 2 cosine of 4x minus pi. The very first thing is to take out the 4. When you take out the 4, you get 4 times x, and this one becomes pi over 4. So the amplitude is this, the absolute value of this, which makes it positive 2. T is 2 pi over omega. So 2 pi divided by 4. 2 pi divided by omega. 2 pi divided by 4 makes it pi over 2. And since there is this period, we normally go from 0 to pi over 2. However, is there a phase shift? So a complete cycle normally goes from 0 to pi over 2. If there is a phase shift, and there is, then it's shifted. So as you can see from here, the phase shift is pi over 4. So this shifts. Positive shifts to the right by this much. Negative shifts to the left by this much. So you add this number to both ends. So when I add it to 0, I get pi over 4. When I add it to pi over 2, I get 3 pi over 4, because pi over 2 is 2 pi over 4. So that means we don't start from 0, we go to the right, we start from pi over 4, and we move. Now, instead of cutting this in 4 pieces, we're going to cut this one in 4 pieces, okay? And to do that, we have to divide the period So this is from 2. This is a complete interval for one cycle. So the period is pi over 2. We're going to divide it by 4. So pi over 2 divided by 4 gives you pi over 8. Meaning what? We start from pi over 4 and we go ahead to the right by this much. So we add pi over 8 to this. And then do the next one, and the next one, and the next one. So to understand that, let's call this 2 pi over 8. So 2 pi over 8. When I add pi over 8, I get 3 pi over 8. Then I get 4 pi over 8 or pi over 2. Then I add 5 pi over 8. Then I add 6 pi over 8 or 3 pi over 4. So we are adding pi over 8. So we are cutting this into 4 subintervals by adding pi over 8 to this one. Again, just look at the very first one. It's pi over 4. Add pi over 8, you get from pi over 4 to 3 pi over 8. That's 1. Then from 3 pi over 8, we add pi over 8 to pi over 2. So take a look at what happens. Pi over 4 to 3 pi over 8, 3 pi over 8 to pi over 2, then pi over 2 to 5 pi over 8, 5 pi over 8 to 3 pi over 2. I'm going to go over that one more time because I want to make sure everybody gets that. So we calculated the t. Because of the phase shift, we moved it to the right by the amount of phase shift. So a complete cycle, we're going to go from pi over 4 to 3 pi over 4. This interval, we want to cut it into 4 pieces. So we divide the t by 4, and then we keep on adding this much to each end. So the first one is pi over 4 to 3 pi over 8. This 3 pi over 8, which is the end point for the first subinterval, is the initial for the next one, and then add pi over 8. Pi over 2 is the initial for the next one, add pi over 8. 5 pi over 8 is the initial for the next one, and add. So what happens next? We are going to plug in. So I'm going to show you a couple of them. So we are going to plug in pi over 4 into this one, 3 pi over 8, and so forth. So I start with pi over 4. If I plug in pi over 4, because you can see that, I get what? Minus 2 cosine of 0, right? Because pi over 4 minus pi over 4 is 0, which makes it minus 2 times 1. It's negative 2. Let's plug in 3 pi over 8. So and I'm going to write it here. So 3 pi over 8 minus pi over 4, 2 pi over 8 becomes minus 2 cosine over 4 times 3 pi minus 2 pi pi over 8. Minus 2 cosine of pi over 2. Cosine of pi over 2 is 0 times minus 2 remains 0. I'm going to plug in pi over 2. So I'm going to erase, maybe I write it here. I want to plug in pi over 2. Minus 2 cosine of 4 times pi over 2. Pi over 2 minus pi over 4. As you know, pi over 2 minus pi over 4 is power 4. Power 4 times 4 is pi, so minus 2 cosine of pi, negative 1, gives you positive 2. If you put 5 pi over 8 here, 5 pi over 8, minus 2 cosine. See, 5 pi over 8 minus pi over 4, that means minus 2 pi over 8, or 3 pi over 8 times 4, so 4 times 3 pi over 8, 12 pi over 8, or 3 pi over 2. Cosine of 3 pi over 2 is 0, times negative 2 is 0. So you have to evaluate each one, and they're all common arcs. You can do them, class. It's really not a big deal. So you get the following. I'm going to leave 3 pi over 4 for you to evaluate. So each endpoint is put into this, and it's calculated. Those pairs, put them here. This is pi over 4, negative 2, 3 pi over 8, 0, pi over 2, 2, 5 pi over 8, 0, 3 pi over 4, negative 2. This is not to scale, everybody. Put them together. Nice, smooth curve. And now you go indefinitely on both sides. Really straightforward, everybody. We'll repeat the same for this example. Y equals 3 sine 2x minus pi. First and foremost, take the 2 out. When I factor the 2 out, becomes 3 sine 2. This becomes x. This becomes minus pi over 2. So the amplitude is absolute value of 3, which is itself. T, the period is 2 pi over omega. The number sitting in front of x, here or here, So 2 pi divided by 2 gives you pi. And therefore, we would go from 0 to pi normally if there is no phase shift. This indicates there is a phase shift of pi over 2, so you have to move this to the right by pi over 2 because of the phase shift. So what happens is 0 becomes pi over 2. Pi is 2 pi over 2, and pi over 2 is 3 pi over 2. Now we have to cut this period pi into 4 equal parts. Becomes pi over 4. This is the initial point for the first subinterval. This is the last point for the last subinterval. So keep on adding pi over 4. So for example, if I add, and remember pi over 2 is 2 pi over 4. If I add pi over 4, I get 3 pi over 4. So just so you see how that works, if I add pi over 2 and pi over 4, I get 3 pi over 4. So the first subinterval goes from pi over 2 to 3 pi over 4. The next one goes from 3 pi over 4 to, now we are going to add pi over 4. If I add pi over 4, I get 4 pi over 4, or simply pi. So the next one is obviously pi, and then add pi over 4, 5 pi over 4. And the next one is 5 pi over 4 and 6 pi over 4, which is 3 pi over 2. So we get those endpoints, those subintervals. So I'm showing you, for example, this one was this one. Okay. So evaluate the original function at those endpoints. So again, I want to show you how we evaluate them by looking at a few points. So let me clean up the mess. So I'm going to put pi over 2 here. When I put pi over 2, I get 3 sine 0, which is 0, because pi over 2 minus pi over 2 is 0 times 2 is 0. If I put 3 pi over 4, I get 3 sine 2, 3 pi over 4 minus pi over 2, I'm going to write it as 2 pi over 4. So it's 3 times sine of, this is pi over 4 times 2 is pi over 2. So 3 times sine of pi over 2 is 1, we get 3. So just for the sake of argument, so we understand what's happening, this one means the pair pi over 2 0. This means the pair 3 pi over 4 3. Now let's add pi. Okay, so we are going to go with pi. If I put pi here, I get 3 sine 2 times pi minus pi over 2. As you know, this is pi over 2 times 2 becomes pi. 3 sine pi, sine of pi is 0, so you get pi comma 0. I'm going to assume you can figure out the rest of them, okay? Just to mention it to you. If I put 5 pi over 4 minus pi over 2 is 2 pi over 4, okay? We get 3 pi over 4 times 2, 6 pi over 4, or 3 pi over 2, sine is negative 1 times 3 is negative 3. So take a look. You put 3 pi over 2 minus pi over 2, you get pi. 2 times pi is 2 pi, sine is 0. So those are actually pretty easy to calculate. Now plot those pairs. Pi over 2, 0. So first of all, you go from pi over 2 to 3 pi over 2. So this is the beginning, this is the end for one complete cycle. Pi over 2, 0, 3 pi over 4, 3, pi 0, 5 pi over 4, negative 3, 3 pi over 2, 0. Put them together, looking like that. That's a complete cycle. If they ask for a complete cycle, you're done. They didn't. You go indefinitely on both sides. That's the graph using the 5 key points, everybody. All right, we want to find the amplitude, period, phase shift, and graph. First and foremost, we take the common factor of 4 out, and this becomes x, this becomes minus 3/4. That's the first thing you want to do. Y equals 2 cosine 4x minus 3 pi minus 1. You take the 4 out. And therefore, the amplitude is the absolute value of 2, which is 2. The period is 2 pi divided by 4, meaning pi over 2. Normally, we go from 0 to pi over 2, but there is a phase shift of positive 3 pi over 4. Again, please understand, positive. If it's negative, you add a negative number. So phase shift is 3 pi over 4. You add 3 pi over 4 to both ends. So a complete cycle starts when you add 3 pi over 4. This becomes 3 pi over 4. This is 2 pi and 3 pi, 5 pi over 4. It starts at this point and it ends at this point, one complete cycle. We've done this before. Divide the t by 4, you get pi over 8. And keep on adding. So this is the beginning. Add pi over 8, just as an example. I'm going to do a couple of it. So this is where we begin, 3 pi over 4 plus pi over 8. And we are going to say this is 6 pi over 8. So we have 7 pi over 8. So that means the following. 3 pi over 4, 7 pi over 8. Now, the next one is 7 pi over 8. And class, if I add pi over 8, what do I get? 8 pi over 8, or simply pi. Now, I'm going to have pi, and then add pi over 8 to this one, I get 9 pi over 8. I'm going to keep 9 pi over 8, and I'm going to add pi over 8 to this one, I get 10 pi over 8, 10 pi over 8, or 5 pi over 4. So I get those, and these are the subintervals. Again, notice I start with this, and I'm going to add pi over 8. It creates those 4 subintervals. One complete interval, cut it into 4 pieces. Now I'm going to do 2 things. First, I'm going to put this into the original one, including the -1. Then I'm going to ignore the one because I want to show you actually in essence both ways. But to do so, let me clean up the mess. And if I put 3 pi over 4 here, so first I start with something you can see the answer. If I put 3 pi over 4 here, that becomes 0, right? So it becomes 2 cosine of 0 minus 1. Cosine of 0 is 1. Okay. If I put 7 pi over 8, so that means the following: the pair 3 pi over 4, 1. So that's one pair. I'm going to put 7 pi over 8. So 2 cosine of 4 instead of x, 7 pi over 8. And because it's 3 pi over 4, I'm going to change it to 6 pi over 8, which means this is pi over 8. 4 times that is pi over 2. And that's -1 because cosine of pi over 2 is 0. So that means the following pair. Let's go with pi. So 2 cosine brackets 4. Now x is pi minus 3 pi over 4. Pi minus 3 pi over 4 is pi over 4 times 4 is pi, so we get 2 cosine pi minus 1. Cosine pi is -1. So that means the pair pi, comma, -3. And 9 pi over 8, if I put it here, minus 6 pi over 8, I get 2 pi over 8. 4 times 2 pi over 8. Now 9 pi over 8 minus 6 pi is 3 pi over 8 times 4 is 12 pi over 8 or 3 pi over 2. Cosine is 0 times 2 is 0, so it gives you -1. So 9 pi over 8 gives you -1. 5 pi over 4 minus 3 pi over 4 gives you 2 pi over 4 pi over 2. Pi over 2 times 4 is 2 pi, cosine is 1 times 2 is 2, minus 1 is 1. So those are the pairs. Again, I hope everybody can handle it. I showed you how to evaluate a few of them. Any of them I haven't, you should be able to do that. So we can plot those pairs and graph them, and that works fine. But let's go back here and say if this is the answer with the -1, if we didn't have the -1, then this becomes, just add 1. This becomes 2, this becomes 0, this becomes -2, this becomes 0, this becomes 2. So again, so if we are looking at this part, okay, and so if you plot them, it looks like that. 3 power 4, 2, 7 power 8, 0, pi -2, 9 power 8, 0, 5 power 4, 2. Put them together. That's one complete cycle going definitely on both sides. That would be this graph or this graph, this one or this one. What is the effect of that? Shifted down by 1 unit. That's what it gives you, those pairs shifted down by 1 unit. So this entire graph comes down by 1 unit, looking like that. Okay. So that's how you graph them. I believe it's pretty straightforward. Let's look at building sinusoidal models from data. So steps for fitting a sine function, y equals a sine omega x minus y plus b. By the way, you could use either sine or cosine. Normally we use sine. And so here's what you need to notice. A basic sine function looks like that, with no phase shift starting at 0, 0 with the x-intercept and y-intercept. The maximum occurs 1/4 of the way at power 2, 1, and the minimum occurs at 3/4 of the way, 3 power 2, -1. So how do we find the amplitude? We know the amplitude is 1 here. So the max minus the mean divided by 2. So determine the amplitude of the function, largest data value minus smallest data value divided by 2. Max minus mean divided by 2. Max is 1. Minus -1 makes it +1. I want to make sure you understand that. In this case is 1 minus -1, which makes it 1 plus 1, which makes it 1. That's how you arrive at it, okay? The vertical shift, you add them up, divide by 2. Notice 1 plus -1 is 0, divided by 2 is 0. There is no vertical shift. So add up the max and mean and divide by 2. So determine B, okay? The shift up and down. Largest value plus the smallest value divided by 2. Max plus mean divided by 2. Determine omega. Since the period is t, the time it takes for the data to repeat is 2 pi over omega, right? So omega is 2 pi divided by t. For example, over here, omega would be 2 pi divided by 2 pi, which is 1. Now the phase shift, also known as the horizontal shift. Determine the horizontal shift of the function by using the period of the data. Divide the period into 4 subintervals of equal length. Determine the x-coordinate for the max of the sine function and the x-coordinate for the maximum value of the data. Use this information to determine the value of the phase shift pi over omega. So you cut it into 4 subintervals. The first one is where the max is going to occur. So when you cut it into 4 pieces, look at the very first piece, right? So right after the 1/4 of a period, pi over 2, this is where it's normally happening if there is no phase shift. But when it doesn't happen on 1/4 of the way, you'll see how much it has moved to the right or left, and you can figure out the phase shift. That difference is the phase shift. Um, I will, I will look at an example of that. Let me erase mine. So given this format, take the omega out, the absolute value of A, that means the amplitude is max minus mean divided by 2. B is max and mean divided by 2. Period is 2 pi over omega, therefore omega is 2 pi over t. Phase shift of pi over omega, which we will figure out. Write the equation of a sine function such that the amplitude is 3t is 3 pi, 5 over omega is negative 1/3. So we are going to look at this, okay? This is what we are going to need. A, omega, 5 over omega, B. The absolute value of A is 3, so this is either 3 or negative 3. And will if it's no information, you keep it in general as positive. We know that t is 2 pi over omega, therefore omega is 2 pi over t. Omega is 2 pi over t, which is 3 pi, therefore omega is 2/3. Pi over omega is given, just plug it. So 3 sine 2/3 x plus 1/3. It's important to know it's minus here, right? So minus because this is negative, plus 1/3. And so if you distribute, you get the same 3 2/3 goes in there times 1/3 is 2 over 9. So it depends how you have it, okay? But I wanted to show you both ways. Pretty straightforward. Example 5, draw a scatter plot and find a sinusoidal function of the form y equals a sine of omega x minus 5 plus b that fits the monthly temperature data for Indianapolis. So here's the given information. And here's the synopsis of how we find every aspect of what we just discussed. So first, What is a scatter plot? That means plot points. For example, January 1st is 28.1. February 2nd is 32.1, and so forth. So we are talking about month of 1, 2, 3, and so forth. And so we have 12 months along the x-axis, the horizontal axis, and along the vertical axis, we have the temperature. Okay. So this is starting with the first month, 0, and this is first month, second, 2, 3, 4, 5, 6, 10, 11, and 12 months. And so, for example, January 1st is here at 28.1, and February is here, he's here, and so on and so forth. So you scatter plot, that means the pairs, 1 comma 28.1, 2 comma 32.1. Okay, that's not January 1st, that's January. So this means the pair 1 comma 28.1. This one is 2 comma 32.1. Okay, so this is 1, 2, all the way to 12. Okay. Now, we know that the amplitude is max minus mean divided by 2. So what is the maximum value? This one. What is the minimum value? This one. Let me erase my work. So maximum 75.4 minus minimum 28.1 divided by 2. 47.3 divided by 2 is 23.65. The vertical shift B is the sum of those two divided by 2. So add the two numbers and divide by 2. 51.75. So far we have the A, we have the B. T is 2 pi over omega, and we know it to be monthly, so it's 12. T must be 12, meaning the period. It repeats every 12 months. Every 12 months we go back to January, right? That's the concept. There are 12 months in a year. So why are we dividing? Why are we taking T to be 12? Because we said monthly temperature. So if T is 2 pi over omega, omega is 2 pi over T, and 2 pi over 12, or pi over 6. That's the reason, okay, everybody months. 2 pi over 12 resulting in pi over 6. So let's remind everybody what happens with a basic sine function. With a basic sine function, 0, 0, and the maximum occurs at pi over 2. That means 1/4 of the way. So let's write the assumption. The assumption is should be 0 here. This should correspond to 6. This should correspond to 12. I hope everybody understands what I'm getting at. 12 months. Half of it, 1/4 of it, that means 4. So at 4, month of 4, okay, if you divide it by 4, month of 3 must have the maximum. Again, assuming there is no phase shift, everybody. So T is 12. Maximum occurs 1/4 of the way, say arc number 1 at top of arc number 1. So T divided by 4 must be 3. So month of 3 must be having the maximum temperature if there is no phase shift. But it doesn't. It happens in July, month of 7. So their difference must be the phase shift. So X coordinate of the maximum value July is going to be 7 instead of 3. The expectation is 3 with no phase shift. But we know it happens at 7. So their difference 4 must be the phase shift. So we plug in A, we have it, 23.65. Omega, we have it, pi over 6. Phi over omega, we have it, is 4. B, we have it, we plug in. Again, pretty straightforward. You can distribute pi over 6 and you get pi over 6x minus 4 pi over 6 or 2 pi over 3. So again, it's pretty straightforward. Now, what is going to happen is that if you plug in x equals 1, you should get this number roughly, not exactly. If you plug in x equals 2, you should get the temperature in February. Plug in x equals 10, you should get this temperature roughly. Again, it's not precisely that, but very close to that, okay? This is carefully. Let's do one more. The number of hours of, is example 6, the number of hours of sunlight in a city on the summer solstice, longest day is 15.3 hours. And on the winter solstice, the shortest day is 9.08 hours. It's about 9, it's about 15. Find a sinusoidal function that fits the data of the form y equals a sine omega x minus phi plus b, and we take the omega out. We start from here. The amplitude is max minus mean divided by 2. So 15.3 minus 9.08 divided by 2 is 3.11. Vertical shift B, add them up, divide by 2. 15.3 plus 9.8 divided by 2, 12.90. Okay. We're talking about the sunlight. We're talking about the longest hours for a day. So we're talking about 365 days. So data repeats every 365. It's about 365 and 1/4 roughly. So this is, we're just taking it to be 365. So T equals 2 pi over omega is 365 days. So omega is 2 pi divided by 365. So let's plug in. We have the A, 3.11. We have omega 2 pi over 365. We have B, 12.19. Looks like that. And minus 5 over omega, we haven't discussed the phase shift because there's not enough information here, but how do we know what's the phase shift and so forth? We are going to look at that concept, everybody. No, the value of phi can be found if the day and the month is given for each case by subtracting 365.4 from the longest day. Remember what we did in the previous one. The maximum occurs 1/4 of the day. The maximum is 1/4 of the period. It's supposed to happen when you take the period and divide it by 4. It happens there, no phase shift. It happens anywhere else, the difference is the phase shift, okay? So we are looking at the same question. Here's part B. Predict the number of hours daylight on the daylight on April 1. Assume x equals 91, and we are going to look at this piece of information that is given. The summer solstice occurs on June 20th, 21st, or 22nd in the northern hemisphere. So it depends on the location. And around December 21 or 22 in southern hemisphere. Let's assume it happens on day 172. So that piece of information is given. Now we can figure out the phase shift. So again, let's look at a basic sine function. The maximum occurs when you divide the t by 4. 2 pi divided by 4 happens at x equals pi over 2, and it's equal to 1. So 365 divided by 4. First of all, this is 0, this is 182.5, this is 365. This one, compared to pi over 2, divide this one by 2, and you get 91.25. So this point, at this point, the maximum occurs. 365 divided by 4. Pi over 2 would be equivalent to 91.25, 1/4 of the way. But if it happens on a different day, in this case 172, what is the difference? The difference is the phase shift, 80.75. Now we can plug in. We had this in the previous page, and now we also add this part. For part B, predict the number of hours of daylight on April. Assume x equals 91 here. So for that one, you're going to replace the X with 91 and you plug into a calculator and it gives you 12.74 hours. In other words, 0.74 is almost 0.75, about 45 minutes, 12 hours and 45 minutes, which means this is a pretty good approximation as to the number of hours per day. You just plug in X representing the number of days, and that can predict the number of hours on that day.